beautiful autumn day here
It is.
in Vancouver.
I love the rain.
Actually, I think I do too. Especially, you know, in light of the fact that we need it so much. Feels like quite a gift.
Actually, we should give a lecture on survival in the rain, how to embrace the rain rather than hate the rain.
You know what? We could come in with our ponchos on. Because ponchos are the key.
Oh, look, we're recording. Hey, good morning, everybody. Good evening, good afternoon, wherever you happen to be.
And even if you're not in the rain, it's a beautiful day here in Vancouver.
Yeah, it's gorgeous. So we're going to talk about fundamentals of software engineering. You've already seen a lot of this stuff in the fetches that we've been doing in our software.
Oh.
Because you're already using it.
We've actually experienced promises.
Yes.
Have we debugged promises?
We looked inside the debugger.
I really enjoyed that.
At what was happening on a step-by-step.
Yeah, and you went front end and back end, and that's the opportunity to really look at, to pull it apart. But when it's asynchronous, I do get, there's a lot going on here.
Yeah.
There's a lot going on here.
Yeah, and we're going to repeat that in the class. We're going to add the error reporting. If you try to edit a cell, we're going to take it and we're going to pipe all that data back to the user that says, hey, Yvonne is editing that cell.
I love that. I think that's such a great example of concurrency, concurrent access to a cell. If we're trying to write, it's fine if we're reading.
Yeah.
It's not okay if we're writing. I love this, and controlling the locking mechanism. In the old days when we talked about concurrency and we talked about concurrency control, and it sounded like concurrency was a bad thing.
Yeah.
You know what I mean? We must control it. That's okay. That's a good thing.
Well,
Cool.
but we also do have an example in a previous lecture where concurrency was a bad thing, the Therac 25.
Oh, yeah.
Remember, there was two threads.
Yeah.
One was controlling the hardware and the
Yeah.
other one was doing the UI.
Yeah.
And they got out of sync.
Yeah.
And so there was bad concurrency. So it is dangerous.
Well, the whole Mars rover.
Oh, yeah.
That's a fabulous example of priority inversion with concurrency. That's a very expensive mistake, let alone, yeah.
Yeah, you can't send someone up there to debug it.
No, and it just stopped working.
So today we're going to talk about concurrency, as you may guess. We are going to do it in the context of Typescript or JavaScript. Every language has its own model for threading. TypeScript and JavaScript have a single threaded model with a utility that handles a lot of the concurrency for you. So it's actually a lot easier in this language than in someone like Java or C++.
Oh, totally. I think so. I think that, if people are interested in this, there's so much more they can look at.
Would you have a course that you teach about that?
I definitely have that as part of the systems course.
There you go.
It's not necessarily the most loved part of the course because we actually look at the pthread library, which is kind of ancient, but definitely mind-bogglingly cool to see how you try to control this.
So what is the difference between synchronous and asynchronous? These are big English words.
Oh, totally.
Synchronous chronos is time.
Yeah, and we even used this in COVID when we were talking about our classes that were going to be online. We told students, I couldn't believe it. It was like, is this a synchronous or an asynchronous model for the classes? And I sort of thought, does everybody understand that terminology? Yeah. But it became very common.
Yeah. Well, and it's a word that most English-speaking people probably don't know.
Yeah, let alone people English as a second language.
I know.
Maybe, I don't know, but so yeah.
Yeah, so it's really important that you understand what these two terms mean. Synchronous means it's happening, everything is scheduled, and asynchronous means that things are happening in kind of random order.
Yeah, like us.
like posting updates for the assignment extension.
We're a little late, but it's because we love you so much that we post so often. So,
no, I hadn't refreshed my browser, so I didn't see your posting.
Interesting. So that was almost like a concurrency bug between us.
It was definitely a concurrency. Not almost. It was. Yeah.
That was very cool. So yeah, I love this, and I think the model in our minds when we first learned to program. A lot of our students are coming through a line. So programming is fairly new, and just sort of having that single control flow now being augmented with the fact that, oh, I can actually have active at one time multiple flows of control. It doesn't mean parallelism. It means that actually things can be active at the same time. Doesn't mean that they're necessarily going
That's
to be
correct,
overlapping. I think in these slides, I find it sometimes a little bit confusing. So however you want to think of this, as long as you got that idea in your mind,
Yeah.
that, hey, it's not just a single flow chart anymore. We're talking about multiple things being possibly active simultaneously.
And it's in our calc sheet, when you hit a button, there's a whole bunch of stuff that happens. It goes to the server, and the server does some calculation asynchronously, but you're waiting because your request could come after 5 other requests.
Yes.
And so you just wait for all of those things to happen, and then you get your update. But the update from another user may actually get done before yours.
Yeah.
So.
And all of this stuff with web browsers and everything, needing this idea of refreshing from a server, that it might actually get out of sync. Oh my gosh, and then order and lazy updates. I'm not on Facebook, but I've heard that you can see that sometimes people get updated in different orders.
Should we risk it? Let's go look at my Facebook.
Oh my gosh, I'm sorry that I don't know. I don't have Facebook. Can you imagine? How do I survive without Facebook? I don't know. I just missed it.
There, you see, so you saw very quickly, if you go, there you go. There's examples. I'm scrolling down here, and each one of these is a request. It's actually gone ahead. There we go.
Yeah.
Right there. That was basically what Facebook is doing here. It actually uses the React framework. They built it.
Yeah.
So basically, they fetch ahead. So you can see the ones that they fetched ahead.
Yeah.
But if you go down here, there we go. I ran out of the buffer. It then goes and gets more.
It's a lazy update.
It's a lazy update, but they do actually do the right thing, because if you look at it, here, let's go get force another update. I'm now pretty good here, and if you go back, and it has
a lot of stuff cached.
A lot of stuff cached, but then you force it update. What's interesting about their forced update is that it fetches like the next 10 or something like that.
Right, and 2 different users. Thank you for sharing that. That's always risky to take your personal, but thank you for that, because that's a great example. But so if I was modern like you, and we were getting the same updates, we might see them in different orders.
Absolutely.
And if these were actual rights to our bank account or something, not that we have a joint bank account, but that could be problematic. So yeah, this is a whole world of really exciting stuff. I love this stuff for sure.
So when do you use asynchronous programming?
Yeah, that's a really good question. I mean, because if we're saying that it's a little more complicated, you don't want to just use it all the time.
No.
You don't need it.
Yeah, and it adds a lot of complication, and it adds a lot of risk, as we saw from Therac 25.
Oh, yeah.
Yeah, so they should not have used it. That was a very simple, you've got your UI, it sets some parameters for the hardware. It would be perfectly reasonable to have a go button that then goes and sets the hardware up, and then when that hardware is done, you get the next command. Yeah. But they did it differently.
To make it synchronous.
Yeah, to make it synchronous.
Yeah.
And so really, independent tasks that are safe to be implemented independently is what really is the task here.
Yeah, which is a wonderful opportunity for getting things to go faster, because they actually can be done at the same time. Not saying that they always are done at the same time, but all of a sudden that whole chronos, that whole timeline shrinks because they're actually overlapping.
Right.
But they have to be able to overlap.
Yeah, and typical, so if we do it in real life, and we're going to do a couple of fun exercises in class. So come prepared to have some fun in class. But
isn't class always fun?
It's always fun. But come prepared again, because we're going to do an exercise. But this is big. So if you look at a supermarket, there's if you can go choose your lineup, then it is asynchronous programming, because every cash teller is processing people independently. So you may go to the shortest line.
Yeah.
And it's the longest one.
Oh, isn't that always? Yeah. I love the skeleton at the back of the line up here with a purse. That's right.
Been waiting for a long time.
Yeah, been waiting for a long time.
And then synchronous programming was McDonald's self-service, because you order and then it's like, but it actually goes into an asynchronous backend.
Yeah, this example is very interesting to me because I sort of see multiple self-service booths there, which would be a lot like the multiple, cashiers. I'm not really sure about this example, but let's go into code because code makes more sense.
Yeah, I think what this example is trying to say, if you're the only customer and there's only one of these, then it would be synchronous.
That's very odd.
And, yeah.
That's all right. And this is it. When we try to come up with these real world examples, sometimes I can twist them and what's the difference?
Yeah. Okay. So an e-commerce system. So when I was working for Amazon, we had my team put the Prime badges on the order document.
Right, we saw that in class. You pointed out, you said this is what it took to put the Prime.
So, but basically what happens whenever there's an order, an e-commerce center, there's all these workflows that happen. Mm-hmm. Go get all of the items that refer to rubber duck.
Yeah.
You go fetch them, and then you have to go, fetch the items. You create the CSV file for those items, and then you send the order status.
Nice.
So the fetch item, if you do them in order, is going to take you 23 milliseconds.
So this isn't somebody ordering yet. It's just to show them what they could order.
This is, so basically, I think this is a cart. So you go get all of the items in the cart.
Okay.
And then you create the CSV file for those items.
Okay.
And then you send an order status to the fulfillment center that says these things are going to be shipped to Rancho.
So there is an opportunity to overlap here, you think?
I think so.
Yeah. So interesting that they're making a file out of it all. Why do they have to make a file out of it?
Because you want to transport the information.
Oh, but can't you do that over the wire?
But that is going over the wire.
Well, why write it to a file?
Well, they're creating a CSV file. They don't necessarily have to write it to a file.
Oh.
It could be in core.
Why would they write it to a file?
For permanence and for logging.
Yeah, okay.
For debugging.
So, and that could be slow.
Yeah.
Oh, yeah, gotcha. Okay, yeah, so they can write to a file. They can create a file. It's interesting, though, right? Yeah, I think there's lots of opportunity here. So there's a few wrinkles in this example too, which is great.
So you could send if you could send the order in before you had all of the CSV file, you could actually send the order in with a promise that the CSV file is going to follow later.
Oh, a promise. Don't you have to finish fetching before you send the order status?
No, you have a promise that says there will be a CSV file that will be here at some point.
So you're not even done your work.
No.
Can we do this with our assignment?
Yeah. Well, we already do it with our assignment. Whenever we fetch from the server, we're still updating the screen. React is updating the screen.
But I mean, when our assignments are due.
Yes.
Okay, cool. So that overlap saves us time.
Yeah. So the pros of asynchronous programming is primarily that the user can continue to be engaged. When you, on the Amazon detail page, there's 250 services that render all of the stuff above the fold. And then there's about 500 or 600 services below the fold, and they have a lower latency. So when the user does scroll down, they can see them.
Those 250 services, Are they all running on the same machine?
Nope, they're all running microservices. They're all different fetches.
So there's real opportunity to make sure that they're all going simultaneously.
Yeah.
Gotcha, but they could theoretically.
Well, you could do it all in order.
Yeah.
Yeah, but again, back to this example here, if this were, if you're building your detail page, you're going to get the image for the object, get the price for the object,
Yeah.
Is this person able to have a Prime membership for this?
Yeah.
What is the rating of this document? Is it of this item? Is it 4.5 stars? Is it 5 stars? Each one of those is maintained by a different backend service.
Right.
And so, and each one of them takes about a second to get, right? So but it doesn't take a second to get, it takes a second for them to do the computation.
Mhm.
The data they send you just comes through right away.
Right.
So you partition it across 250 different services.
Wow.
They all spend their 1 second doing it,
Yeah.
and you can update that, all of that data in less than 2 seconds, which is the requirement.
Or people walk away from
Yeah.
the website.
Oh, yeah.
Wow. What's that? So customization?
When we ran the badging for Prime, we were delivering a URL for a badge, which said Prime.
Right.
Right, and that's all we did.
Yeah.
And we had to do it very fast. So we had all that document that was coming down. We looked at all of the data that was there.
Yeah.
And then we would decide whether you're going to get a Prime badge or not.
Yeah.
Right?
Yeah.
Now, when Prime was launched in France and in Spain, they called it Premium, because it's a Spanish and French word.
Yeah.
And then they rebranded it to Prime.
Oh, everybody had to say Prime.
And so that was, from our perspective, our task was, we just stopped giving the URL to the Premium, and we started giving the URL to the Prime, right? But there was about 200 teams that had to do work for that. But we were able to solve our problem very quickly, which was, okay, from starting on this date, we will no longer, so we were able to customize our particular portion independent of all of the other stuff.
Nice, very nice. And that's got to be the mainstay of Amazon.
Yeah. And well, I mean, AWS started because they had leftover computers after the Christmas season, and they didn't know what to do with them, so someone decided to rent them out. That's basically how AWS started.
Wow. And there's scalability for you right there that, even though you might be adding more and more functionality, you're able to maybe do that in a way where you can get this parallelization because you have all those computers, and then still the time for you to get things done stays pretty constant, even though you're adding all these things, because it's all at the same time.
Yeah.
Wow.
And so basically, those are the benefits. It's more complicated. You now have 200, you have a whole bunch of different processes that are doing stuff, and you have to it's like herding cats.
Thinking about their dependencies in case there were some. So do you think programming languages have helped us with the complexity? Some do things different with this than others, and even the evolution.
Well, JavaScript is a classic example of a programming language with an underlying computational model that serves a particular need, which is managing concurrency in a very simple way.
Yeah, which makes it less complex.
It makes it it's still complex. You still have to have a method for waiting for something to happen and then doing something.
Oh, because you need to make sure that you don't go ahead and charge the user for something that hasn't been recorded in their order yet. So these dependencies. So there's a coordination.
Yeah. Well, and in CalcSheet, we put all of the computation on the server. Yeah. Right? And the server executes things one at a time. Yeah. So there's never, so that every user sees the same computation on the spreadsheet.
So a centralized place where modifications are taking place. However,
latency.
Yeah.
You gotta wait for it, because if you do this, if you write a calculator for yourself in React and you don't have a backend server, it's super fast. Works just like that.
Well, when they're running on local hosts, it's pretty quick.
It's pretty quick, yeah.
Yeah. And then compatibility, because now we're gonna bust things up and potentially get this win if we can figure out how to do it and not have errors in it. But compatibility, because now we're busting things up. And
Well, there's when you have APIs, there's a thing called an API contract. Where you if I call this function with these parameters, now with scalability, when you start distributing things into different worker tasks, you have to have a data contract. That the data, so you need to have compatible data going back and forth.
Yeah.
Right. So the naming of the data is really important, because if my document says user and you're expecting user ID.
Oh yeah.
It says, so the compatibility becomes really difficult, because it's basically a really complex API design.
Absolutely. Okay, let's do it. Oh no, this looks crazy. We've seen callbacks, Phil.
We've seen callbacks.
It was one of the first nights we used a callback, I think, when you did buttons.
Yeah.
I think so.
Well, those are the React callbacks.
Oh, okay.
Yeah.
So this isn't the same as this callback.
Yeah. So in JavaScript originally, you basically had this thing, database verify user, and then you would pass in these callbacks. So it would be callback errors. So if an error occurs, you call back this error. So basically the database verify user would go and verify that the user and the password's okay. That would take time. That would happen over time.
Right.
On a separate task.
Okay.
And then when it was done, it would then call back this error. So this code, if error and else and database get roles and error and callback error, and then the callback user info roles, right? All of that code was carried around, and your code started to look like this.
Massive indentation.
Massive indentation.
It's
right?
like the geese flying south.
Yeah. Yeah.
And there goes our Canada geese.
But if you look at it, it's like, this is your happy path is right here.
Well, I would never have found that happy path.
But look at all of this stuff. So this is all dealing with errors and stuff like that.
So please tell me we're not going to ask our students to do this.
No.
Yay. That's just approach one.
So
you like this approach much better, don't you?
Right. So a promise. So basically, it's a different way of thinking about this.
Okay.
Imagine if I said, Yvonne, go to the fridge and get me a sandwich.
Oh, because you make the best sandwiches. I'm out of here.
Okay. But there's no sandwich in the fridge.
Oh,
so you came back and with nothing. Yeah. That's an error.
Oh, that's certainly an error.
Yeah,
that is not an expected outcome, and I'm very disappointed.
Yeah, there you go. But basically, whenever so async actions, and we'll do this is the exercise we're going to do in class, is do something.
Okay.
And then if you succeed, then do something. And if you don't, if something gets rejected, so go get me a sandwich, you bring me a sandwich, then I eat it.
Okay.
But if you go there and there's no sandwich, you say there's no sandwich. So then I say, well, then go buy me one.
So you're going to take a different course of action based on what happens when I try to do what you've asked me to do. And it's fair. Why is it so critical that this is set up in this promise? And like, this seems like a lot of complicated stuff when it's just, hey, it didn't work out.
It's primarily so that your code can, it's trying to have a language that mimics how we think about things, right? So we are well aware of being given a task.
Yeah.
And then I come back to you and say, hey, Yvonne, I didn't get the lecture ready in time.
Yeah.
And then you go, you're a Dinkelfritz. And I go, oh, okay, sorry about that.
But it happens.
But it happens.
Never with one show, but it can happen.
But then once we have the lecture, I said, well, let's go do the recording.
Right.
And so, like yesterday, it was, let's do the recording, but Yvonne can't make it in. So
Right.
then we did it today.
Yes.
Right. So it's kind of, think of it as an envelope
Yeah.
with a task.
Okay.
And then once that task is either completed or not, the envelope has a whole bunch of other instructions in it.
Okay. And the most important thing is that when you asked me to go get the sandwich, you're continuing on.
Oh yeah, I'm talking here, blah, blah,
You're
blah.
still doing the lecture.
Yeah, I'm doing the lecture. And
This
then
is all asynchronous.
yeah, the asynchronous Yvonne.
I am the asynchronous evil. Okay, and so, and the nice thing is, if I fail, it's not like you're gonna be held up.
Yeah.
You're gonna just continue on. And
Mhm.
there's that whole, with synchronous, we kind of go through our control flow and maybe things do fail, but there's just not this maybe opportunity to have this failure mode even. That is, oh, wow, I could actually be waiting a long time if there's no sandwich.
Right.
Right.
Yeah.
I got to get on with my life.
And again, it's about the language that we use. So if we go here,
Yeah.
it's like, hey, go get me a sandwich. If there's an error, come tell me.
Yeah.
But
It looks like you wait for me.
I do. Well, I know the callback actually will execute. It does. But what's interesting, what I like about this, is that when you look at this, and you look at the code down here, look at how this reads. Verify the user. Then, that means you succeeded, then get the roles. And if that succeeds, then go to the database and log the access. And then the final result is you do whatever you are supposed to do. And that was the final callback.
Right.
But these are all the positive things that happen.
And you could have an error when you go to get roles.
Yes, absolutely. But here what we can do is we can have a big catch-all.
Yeah.
Because when you look here, error was just callback error. Something happened. Something bad happened, something bad happened, something bad happened here. Da, 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 da. But what we're getting here, and basically, we get an error. So this verify user basically has an error and so this, if that's true, then we call back. If that error doesn't exist, then we do something else.
Yeah.
If that doesn't happen, but we're not doing the positive. It's very difficult for read.
And so it's really about not different functionality, but a different representation of the same functionality.
Right.
And it's an improvement and it's evolution within a programming language.
Yeah.
Nice.
And Java has a similar concept called futures.
Oh, promises and futures sound very positive as opposed to, I think you said callback hell.
Yeah.
So did you program a lot with callback hell?
Mm-hmm.
Yeah. And now you're very happy to have promises and futures.
Yeah.
Okay.
Yeah, my the app that I have up on the Apple Store is an Objective-C with callback, and I have callbacks within callbacks within callbacks.
How nested are you?
Oh,
Does it go off the screen?
it does.
Oh, gee. So this is not going to go off the screen. We have the same kind of functionalities, but in a much more positive way. We still may encounter errors at any of the .thens.
Yep.
And we're going to go do whatever the error is, but this is just a much easier to read, potentially easier to maintain. Oh, it's a good time to be learning a program.
Yep. So what is a promise? So a promise is essentially an object that has a whole bunch of code attached to it of what to do when things succeed.
Okay.
Right. So basically, this get roles here is going to return a promise that has either a resolve or a reject parameter, and it will do the connection, and then it will resolve to the result.
Okay.
Right? So that's all kind of hidden into this here.
Right, because now I'm seeing the keyword promise. Before, when I was seeing this verify user, I could see it as a function that didn't look too bad. These dots are kind of new, but now I'm actually seeing that the functions that are getting called in those dot thens actually are returning promises.
Right.
And each one of them kind of has this parameter setup that really gives me that kind of, it's either going to work or it's not.
Right.
Haha.
Now, that second implementation still looks like it's got a whole bunch of indentation, right?
Well, not as bad as maybe that first one, but there's still, yeah, there's.
That's the one on the lower right is using the kind of promise syntax with the then.
Oh, I see what you mean. Oh, okay, yeah.
So you've got, okay, get roles is a new function for user info. I don't know why they changed user info to username, but that's okay. And then we're going to return a new promise, resolve. And so this promise takes two parameters, resolve and reject. And then it basically will do a database connect. Then the connection goes to, so basically then is a arrow function that takes connection to connection query, get roles SQL.
Yeah.
And then if that succeeds, that's going to be a promise that will result in a result, and then that result will resolve to a result. And so then you have the basically
that's
more
how it's
verbose.
flowing.
Yeah.
Ah, oh, sorry, I interrupted, but you said
No.
that's it. Are you saying that bottom one is a little more verbose, or?
It's walking you through kind of the steps. Then.
Yeah. I like that. But I can see how this is a bit of a learning curve to understand how result kind of flows through. And you're not really doing, well, I don't know. That's really interesting.
Yeah.
And so you've got this, a couple of things in the learning curve here, this idea of result and resolve kind of using result there and using these dots, but you're going to say this is the wave of the future. Go for this bottom implementation.
I think it's what we have now until they figure out a better way.
Yeah, exactly. Maybe our students will figure out a better way. But yeah, that's pretty cool. Oh, is this a better way?
Well, so we did have promises. We still have to rely on callbacks that are passed to and then. But we want to be able to wait for something.
Oh, so there's a little bit more of a coordinated.
Yeah.
And really explicitly identified, hey, I'm waiting around for you.
Mm-hmm.
Okay, that sounds good. I recognize that with sort of in some of the pthread programming too. This is great. Okay, cool.
So basically,
note. Okay. Oh, look at this.
Yeah, so we'll be going through this in class.
Good.
So for the practice.
So we'll go, this will be our practice exercise.
Yeah, so we'll skip over this for the lecture, I think, for now, because we'll. I think this is more of the hands-on. Let's do it. So feel free to look through the slides for this as we go through this, but this is a hands-on.
Chaining promises.
Yeah, so basically, you can have a promise. So, up here, this fetch promise will return a promise. So it gets pretty hard. You just need to practice, right?
Well, yeah, I sort of feel like for us now, we definitely want to understand promises, async await, get some hands-on experience with it, understand that conceptually,
right,
the ideas actually can be explained in ways that we can play with in class that really help us understand the mechanics of what we need to think about. And then the code for it is a learning curve for sure, but we can get there, and hands-on practice will do it. And it's there in the calculator spreadsheet thing. And so, yeah, okay, I like it. I can handle that.
Yeah. So we'll be going through this in class. If you do go through it and before, then that's great. Then you can teach the lecture instead of us.
Yeah.
So you've seen the fetch API gets a response. So this is code that you're actually running in your account sheet. So we do a fetch of,
Right.
we basically every tenth of a second, we do a fetch of the back end.
Is a fetch always a fetch of a?
A fetch is a command that will take some time,
Yeah.
and a fetch is always returning a promise.
Okay, interesting, because I used fetch a lot.
Yeah.
Without thinking too much about what it was doing, it's just I gotta fetch something from a
Yeah.
URL.
So when you do fetch, you say, hey, go to this URL
Yeah,
and get this data,
yeah,
and then your code keeps running.
right. But what if I can't do anything until the data comes back?
Then you have to design your UI. So in our particular case, if the server is down, you'll see holding and holding, and
I saw that.
yeah, that's the response. That's basically the front end saying holding. It should be either server is down or something like that.
Holding's lovely.
Holding.
And when they're running localhost, obviously, they might not be running into that so much, unless they actually
Unless
haven't
the server-
started up their server.
Server, exactly, yeah.
Oh, fantastic. Love this.
And then catching errors. Again, you'll see this in your code where we have fetch and there's error catching. If the data is incorrect or stuff like that. We are trusting our back end quite a bit in our calc sheet. So we're not doing a lot of validation of the JSON documents that we get from the back end.
Yeah, well, that makes sense.
Yeah.
I mean, it's important to think about how to do this in production and so seeing all this is great, but for right now, we're kind of, we're just learning. I think that makes sense. You can always, anybody that wants to do more error checking, do not hold back.
Yeah. And so if you go into your debugger, as you see, and we'll do this in class, you can see there's a promise and that's actually fulfilled. And you can dig into it and you can go see what's inside that promise.
That's very important to have fulfilled promises. That's fabulous.
But it's undefined.
Yeah.
So.
Well, and how interesting, I sort of feel like this opportunity to really think about this relates to other things that maybe are new products and stuff that I know that you've worked on too. Like, is there a relationship here between step functions and?
The step functions is a workflow controller that allows you to do things asynchronously.
Okay.
And it's like load a document.
Okay.
And that might take 5 minutes if the document's big.
Yeah.
And then the step function actually is doing this thing at a higher level.
Interesting. So it's actually a scaffolding to help people with asynchronous programming.
It is. And the way that it works is, so the way that one works is you start off and you say, go do this task. And it could be a Lambda function. It could be a call to your EC2 instance. It could be a fetch from a web page.
Yeah.
And then the worker goes and does that. Yeah. And when it's done, it comes back to the step function and gives a result to the step function orchestrator. And the step function orchestrator looks at that data and then decides what to do next. Now, some of those tasks can take up to a month.
So what our students are learning here really will set them up for programming at that scale.
Right. And an example of where something takes a month.
Yeah.
It's approvals.
Oh, yeah, I bet.
Because one of the things you can do with a step function is you can trigger essentially an email to a person, approve this or don't approve it.
Wow, so it's that whole workflow that includes humans in the loop.
And that's why it has to be asynchronous, because we're not very reliable as humans.
Do people use step functions much that are AWS clients?
Yes, it's large clients that are using it too.
All right.
And it's whenever you deposit some money into your bank,
Yeah.
You know, it basically, your current, if I'm sending, the Interact thing, the Interact sending.
Yes.
So I send you an email,
Yep.
right? And so that email goes, that's step one.
Yeah.
And you haven't set up auto deposit,
Right.
right? So.
Because I'm not even on Facebook.
So that first step
Yeah.
is that my bank reserves the $1,000 that I'm sending you.
Yeah.
As part of I'm attempting to send this.
Yeah.
And then you could sit on that email for 3 weeks.
Yeah.
Nothing happens.
Yeah.
And then you say, oh, okay, I accept it.
Yeah.
And so then your bank talks to my bank
Yeah.
and says, okay, give me that money. And then that money goes into your bank account.
Whoa.
And then that now sends, at that point, my account is updated,
Yeah.
and that held funds is released to you, and I don't have it in my account anymore.
Wow. And so I'm actually part of the workflow
Yeah.
that must be incorporated into how that coordination works. All right. So this is even though the people that are using that.
But in that example, we had exactly these three things: pending, fulfilled, and rejected. So you could actually reject the $1,000.
Why would I? But yes, I could say no, Washo. I asked for 2,000.
There you go. Exactly.
There you go.
That's not the price we agreed on.
Yeah, exactly.
So then you reject it, and so it
Yeah.
comes back, and so then my bank has to do something with
Yeah.
it.
So even though we're going to learn and use something very, maybe some syntax that we'll learn that is associated, these concepts are so big and so important with modern systems.
Yep.
That's the biggest takeaway. But learn how to do it using the syntax of promises in Java, in Typescript.
And as we've said before, learn how to do it in Java, learn how to do it in Python,
Yeah.
learn how to do it in C++.
Yeah.
Because this whole idea of asynchronous is crucial to your success in your career as a
100%.
software developer.
100%. And you can go too crazy. You can make everything asynchronous, and it didn't have to be. Cool.
So I want to make a sandwich, and I say to...
You're making me real hungry, man.
I know. So I say to one person, go get the bread. I say to another person, go get the mayonnaise. I say to another person, go get the lettuce. And I say to another person, go get the meat.
I love that.
Right?
So,
and then, right. And they all come back.
Yeah.
And I'm like, well, the meat person didn't come back.
Oh, we're just going to have a lettuce mayonnaise sandwich.
Yeah. Yeah.
I wouldn't mind just seeing, we don't know if perhaps the meat person is actually on a plane to somewhere else now. So how long do we wait?
Maybe they're going to Montreal for Schwartz's Deli.
Oh, Montreal smoked meat. Okay, we're really killing ourselves here. But so how do I know when to give up?
You have a timeout. You can set a timeout.
Okay.
So basically you can say, wait for a certain amount of time.
And then can I also launch someone else on that job? Maybe
you can have an error.
Okay, I like it.
So basically, every request you can put a timeout on it.
Mm-hmm.
So fetch has a timeout. You'll get a 404 or something like that.
I love that.
But promise all is a way that you can say send everything, and then you get a single promise back. I personally find promise all to be confusing to use, but it's there.
Okay.
Yeah.
Good. I honestly, when I think of some of this stuff, I'm reminded of when I saw the first web browser that I ever saw, and it was Mosaic.
Yeah.
And I had to go out to UBC to see it. And I remember somebody in the systems community saying something about how, something like a 404. No, we can't possibly include the user in a failed part of the system. That the entire idea of the World Wide Web would be much better if it was just a big distributed file system that did not expose that kind of 404. It's interesting to look back at those days and to think about the arguments that people were making, and are we okay with 404s? Are we okay with asynchronous? Can we deal with people that don't come back with the meat? I think the world has shown that we can.
Yeah, well, and a lot of it is got to do with design. How do you design your front end?
Yeah.
Such that your customer knows what's happening.
Right, and you guys were so good at that.
Yeah.
And I think the big thing too is moving from that space where when we first learn to program, we're typically writing code that's on one machine. But the real, win here is if we're actually running simultaneously on multiple independent machines that can fail independently.
Right.
And so we have to code for it.
Well, but it turns out that when let's say you're running a game on a local machine, you have to load a whole bunch of textures into memory.
Right, this is the whole graphics thing. You know a thing or two about that.
Yeah, it takes quite a bit of time to transfer files off a solid state disk into memory.
Really? There's no mechanical moving parts? Come on.
It's so slow compared, so you could do it in parallel.
You did that, didn't you?
Yes.
You hacked the ELF format, didn't you?
Yeah. So basically, you can speed up your load of when you play a game on your phone.
Yeah.
It loads all of the textures into memory, and it does that also asynchronously. It fetches things because it's a lot faster, just because the SSD drive is that much slower than memory.
Even though we were talking back in the day about it coming off a mechanical disk, SSD is still slow. Yeah, okay, so I buy it. The world is asynchronous. We got to be able to do it.
So in this particular example here, this one here conveniently is not found. So
the name of it.
Yeah.
Oh, we're getting products, we're getting not found, and we're getting superheroes.
Yeah, and so what you're going to get here is that the first one worked, the second one did not work, and the third one did. And so we've basically promised all. So now notice that promises, so fetch returns a promise.
So
a promise is an object.
Yeah,
right?
Yep.
And so now you have made these things. They've gone off and they've started doing their work.
Okay.
So notice that we don't
happened.
have to use this format that we had here. So fetch, then we can say what we did here. We say create an object from this, and there's my promise.
Yeah.
So fetch promise will have all of the, I can then execute thens on that.
Okay, so let me get this right. These first three lines that are setting up these objects actually do run sequentially, but so the first one executes before the second one, but it's not that it's complete.
No, they don't. There's no guarantee that that first, second, and third fetch execute sequentially.
Well, isn't it true that they will start it?
They start at the same time, but let's say that that first promise, that the server required a lot of computation.
Yeah, and I'm not saying it finishes. I'm saying that when we're executing this code, that line of code is hit before the second
the
one.
fetch is started.
Yes.
Yes, the fetch is started.
Oh, so that's the big difference. You're saying started but not completed.
Correct, yeah.
Yeah, gotcha.
Yeah, so basically, it's like, Yvonne, go get a piece of bread. And off goes Yvonne to get some bread. Richard.
Go do it, and Ildar, go do it.
And they start in that order, but there's no guarantee that Ildar won't come back first.
Yeah, gotcha.
Now, what's interesting about this is we didn't get a failure here, right? Because every one of those responses gave us a response. So we did get a response for each one, right? So the first one.
The way the promise is put together.
Well, no, it's because if a fetch gets a 404, it's a successful fetch.
Okay, right. Even though 404 means
that it couldn't find that file.
I don't got it.
But that request to that server resulted in data coming back from that server that you can then say to the user, hey, the not found file is not found.
Yeah. Okay, and so that's at the bottom there, showing the console.log. But we never see fail to fetch.
Fail to fetch is when fetch fails.
Mm.
So like if you have a bad URL or something like that, or your network's down.
Wow. Well, a bad URL. Oh, I see. So you mean that it can't even be parsed
Yeah.
to be done?
You-
Okay.
You call fetch with garbage.
Let's do that in class. Let's
Yeah.
call fetch with garbage. But I love the one that's called not found.
It would be cool if it was found.
That would be really funny.
Yeah. Now, one of the benefits of doing things asynchronously is I could ask 5 people to go and buy me a TV. I could say, you go to Best Buy,
Yeah.
you go to Staples, you go to, I don't know, Home Depot.
Yeah,
Uh,
London Drugs.
The Home Depot is going to fail. London Drugs will succeed. And all I care is that I get a TV.
Oh,
Right?
so the
So-
first one back.
First one back, I'm done. Everyone else, I don't care.
Nice.
Right? And
It's a
so
lot of wasted time and effort, though.
computers are pretty cheap,
Oh,
right? So running stuff on computer is actually quite inexpensive.
relative to losing a customer.
Yes. And so you could have a highly accurate computation, or you could have an approximation.
Whoa, nice. Okay, wow, there's a lot of flexibility with this promise all, promise any, when we have multiple promises. Woo.
Now, but sometimes you want to actually go through the flow in a linear fashion.
Like, you want to make sure that fetch has completed and now you're going to do something with it and you
Correct.
won't continue to do anything else.
Right. So what we can do is we can write async functions that within them wait for things to happen.
Do we throw out promises with
No,
this?
an async function returns a promise.
Okay, so we
Right.
still, okay.
But this is how you build a function that goes off and does something.
Right,
So you basically say, I'm going to give you an async task, but
right.
you have to do these things in this order.
Okay, so it's a little more controlled.
Yeah, so within that async function, you can use the keyword await.
And that is gonna give us that kind of, hey, stop the show, we're waiting for this thing that we know independently runs on maybe a different computer and da-da-da-da, but we're not gonna continue on with anything until we get that back. Oh, wait,
Okay,
that's
so
nice.
this is
Oh,
code
this is
that you
lovely.
have in CalcSheet, that we have in CalcSheet. Basically fetch, if the response is not okay, we throw an error. Then we're not going to process the not okay. We're not going to tell you about 404. We're just going to say, hey, we got an error.
Okay.
Then we're going to convert to JSON. So basically then we have JSON to console log, and then we print it out, right?
So
we
we're
want to
doing this, yeah, I saw that.
we want to do this, we want to change this to, we want to build a function that fetches products.
Oh, so this is a lot like the whole Prime example, maybe, yeah. This is a shopping cart.
So
Sort of
what we're
thing.
going to do here is we're going to define a function called fetch products.
Okay,
And it's going to return, it's going to go and do something, and at the very end, it will do something. So basically, what it's going to do is going to print out the first element in the JSON file that it gets back, the name associated. So on
Okay.
this right here, this is what it's going to do, right?
right.
But what we're going to do is we're going to do a try.
Oh.
We're going to try this. If this is an open, so this succeeds. So response not okay, that's a successful fetch. So basically, we say const equals await. And what await does, it kind of unwraps the promise.
Oh, so it's actually controlling execution flow of this call to fetch.
Yeah, so basically, if you call a fetch, then you have to do a then. But if you call await, you don't do the then, and then you get the response there. So response will now have that value.
Yeah, I don't see any thens there. The dot thens are gone.
Yeah. Now, what we're doing with this await here is we're guaranteeing that this code here will not be run until this does. Now, remember with fetch, it goes off and says, I'm going to go, and you keep doing what you need to.
Yeah.
But we actually want to get this data before, so we want to do it. And so basically what this will do, this fetch products, it will wait until it gets the data from that URL, and then it'll either throw an error, or it'll print it out on a console log JSON, or it will say, if this failed here, then we're going to do catch, and we do it there. So this is, here we have the console. Here's the catch.
Right.
Then, so basically, what do? We do a fetch. Then after it happens, we write the then, and then we convert it to JSON, and then we print it out.
I see. So the thens do give us some kind of control over the sequence here, but we're using await and async, or this is giving us, and we never, interesting. Was there promise all? Did that give us some control too? Yeah, I think you're telling me that this async await with this try catch is the most modern way to do all this, and maybe even bypasses some of the problems with things that we've even demonstrated in previous slides. Okay, good. I like that. This is it. Now, we can't do this one over here.
Right, because first of all, the function doesn't return anything.
Oh.
Right, so fetch, an async function returns a promise.
Right.
Right, and so what you can do is at the bottom there, you can say JSON promise equals fetch product. So that's a promise. And now that so this is an async function that does, it basically, notice that we've rewritten this. So,
yeah, it's very subtle though.
So here we're printing it out.
Yeah.
But here we're going to return the JSON.
Right.
And so what this actually does, it doesn't return a JSON, it returns a promise to a JSON.
Oh, that's a bad variable name, I feel. No?
Yeah,
it's okay.
It's a totally horrible JSON, but it's JSON object, whatever. Anyways, so basically this fetch products will go off and asynchronously fetch that particular product.
Right.
And then we run this function, which basically so basically fetch products returns a promise to a JSON, which you can then use as a parameter for your arrow function here, and then you can print out your console log, right?
Okay, so the only difference here is that on this side, we're just trying to dive right in.
Yeah.
And that's not what that is. We really have to have this format. And it is kind of, there's a learning curve here with the then and the arrow and the, there's stuff. But what happens if you do this? It doesn't even run?
No, you'll get, it won't even compile.
That's good.
Yeah, remember we talked about static testing?
Yeah.
Static and unit and static testing, and it'll catch up for you.
Good. All right. I think we did it.
I think that's it. Anyways, this is not the way that you do concurrent programming in any other language.
But
the ideas are there, right?
Yeah.
And this idea, and really, in my mind, in my experience, I've often got my head around concurrency by thinking about giving people tasks.
Yeah, well, one of the ones that is very popular to understand concurrency now, one of the approaches is to look at what the programming language Go is doing. And Go being developed by Google, and one of the evangelists, Rob Pike, has many, many videos, and he uses gophers. So not people, but gophers to sort of show breaking tasks down. So, okay, so as long as we get the concept, and we actually put it into practice with TypeScript and JavaScript, and we're going to get the ideas. Promises and futures are very similar, so learning this syntax, and that was going to, but overall, this code exists in the code that we're running right now, and that's exciting to go and look at.
Yeah, and it's hopefully you've seen that this step that you've taken now, if you already took web, of course, you know some of this, but basically in your first introductory computer science courses, everything is predictable.
Yeah.
A variable, you set a variable to a number, it has that number.
Yeah.
Once you distribute your systems and you have these random events, well, they're random because, you could call a URL that is really slow.
Oh
that
my.
day, or it's stalled or whatever.
Yeah.
You need to start thinking about how to decompose it. It actually forces you to write a lot simpler code because writing really, really complicated concurrent systems is really hard. And you did mention Rob Pike, and we've already talked about this before, but Rob Pike basically said that debugging is twice as hard as programming. So if you write the smartest code that you can, you're not smart enough to debug your own code. Right?
Twice as hard.
Yeah. I think it's more like 10 times as hard. So that's why I write really, really simple code so that I can be smart enough to understand it and debug it.
Yeah, and debugging. I mean, I think the big thing here with breaking things up and going to external URLs, so, it's great that we can, turn on our debugger to be able to see our front end and to look at our back end. But what happens if that's not our back end? We're calling somebody else's back end and we can't do any debugging of that back end.
Well, you write simple tests against that,
Yeah.
and you see, hopefully you have a tech support from them that they can help you.
Okay, this is going to be a very exciting part of the course. Really looking forward to some fun in the class with you guys. Hope that was fun. It was certainly fun for me. Thank you. I think we need to go get a sandwich. What do you say?
I think so, yeah. Okay, we're going to go get a sandwich. Okay, everyone, see you on Monday. On Monday, we are going to do something really exciting. We'll go through some of this.
Hands-on.
And you're going to cover some stuff from the paper stuff.
I wouldn't mind. I definitely am setting up most of our paper stuff. I'd like to make sure that we're all looking at what we have for our reviewing, and that most of our paper stuff is going to happen October 30th.
Right.
So I know that I'm taking up a lot of class time with this, and I know that that's sort of different to be looking at these papers, but I think it's worthwhile.
Yeah, no, I agree.
And so very short bit on just papers, but let's make sure we get some hands-on here. Make sure, I think we're doing really well with assignment 2. I think that extension was a good idea.
I think so,
yeah. And then we're going to talk a little bit maybe about assignment 3.
Yeah, we'll talk about assignment 3. And the other thing that we're going to do in class, one of the annoying things about the calculator sheet right now is that when you click on an edit, on a cell that's being edited, even if it's labeled as that, you don't get an error message. Yeah. So what we're going to do in class is we're going to build that error message such that from all this, basically the same thing we did for the name, but this time we're going to have all of our colleagues in the class go through and write the code themselves all the way through.
Oh, this is going to be good. So. This is going to be good. And that builds on what we learned in assignment 2 for sure. And all this concurrency stuff for sure. Okay. Excellent. Okay, thank you, you guys.
Bye-bye.
Have a good one. We're going for lunch. I can't get away from food. Oh. All right, we did it.